into starting with the content. So welcome to this I'm actually not allowed to call this a webinar because apparently online calling something a webinar is on the way out. People are sick and tired of webinars. So welcome to this live event, which is not a webinar. So I'll try to keep it to an hour. I'm terrible at keeping time, but I'll try to wrap this up in 60 minutes. And I think we'll start in about 5 minutes at the most to give a bit more people a chance to join. I'll be talking about machine learning. So machine learning is obviously my specialty. I've been doing it for a couple of years now. I'm a bit weird in that I program machine learning apps in C#, which is kind of crazy because 99% of all tools and libraries and technologies out there is Python. It's all Python. There's a bit of R, you know, that's a language, R. So Python and R, and nobody uses C# for machine learning. If you try to build TensorFlow applications with C#, it's just terrible. The bindings don't work. A lot of the calls are designed for Python and they're completely incompatible with .NET. It's just terrible. Nevertheless, I persevered because I figured that this was going to be an awesome niche. Because consider, we have all these C# developers out there, people who are developing .NET in C#, you know, you're used to the tool chain, the .NET tool chain, you know, it's all awesome. And then you want to move into machine learning. And it's really annoying that you have to learn Python before you can actually make that step. And then if you have, I don't know, like a C# enterprise application and you want to add some machine learning to that, you need to program this in Python and stick it into a virtual machine and then add a REST API. And then you need to call into the REST API from C#. And it just gets very messy. So, you know, if it were possible to build machine learning apps in C#, that would be awesome because you can just add the machine learning components directly to your applications. And it's slowly becoming possible. When I started out in machine learning, it was almost impossible. So I had to discover a lot of hacks, basically, to get it to work. The first machine learning course I built was with, I used CNTK, the Cognitive Toolkit, which is like a Microsoft, and the Microsoft answer to TensorFlow, basically. And it works quite well. But, you know, it's still difficult. But now things are changing. So right now things are changing. Microsoft is going full in on machine learning, and C# is finally becoming a first-class citizen, a first-class language to develop machine learning applications. So that's basically what I want to share with you in this event. It's not a webinar, this event. I want to share with you what the market, the machine learning market looks like right now. Why this is a golden opportunity for you if you're a developer. If you're a C# developer or a Python developer or a JavaScript developer, it doesn't really matter. Machine learning is just an awesome opportunity. So I want to show that to you. And at the end of, so like in 40 minutes or so, I will show you an app. So I've got an app in C#, and it's a little machine learning model, and it predicts taxi fares. So you just enter, you know, the distance you're traveling, how you pay. That's basically it. How many people are in the cab with you, and then it will calculate the fare. So the taxi fare that you should be charged. So it's basically just a model that's been trained on taxi prices. So it knows exactly what a taxi fare is supposed to cost. So you could easily build an app around this. You could build a mobile app that tracks your taxi rides and then calculates the fare. And then you can compare that with the fare that you're being charged. And if you're being scammed, you would know right away. So you could build an app out of this right away. So it's 100 lines of code. It's all C#. It's pretty awesome. I'll show you that app at the end of this event. Okay, so the chat will be our main venue of communication. I mean, if you unmute your microphone and you just talk, it's going to get really messy because we're with a lot of people in this event. So the easiest thing is just type in the chat if you have a question, and I will get right to it. You know, I'll see. I've got the chat window open there in the corner of my screen, so I can just respond right away. So what do you think? Shall we start? 10 minutes past 5, shall we get going? Let me know in the chat if you're still alive. Here we go. Awesome, Liso and Konstantin are still awake. All right, let's get started. Okay, I'll share my desktop. And an awesome question by Macmillan. Is machine learning the same as AI? Okay, so AI is a really weird term. Nobody really knows what it means. Machine learning is easy to define. It's building software that learning machines. So if you're building a software that you actually train on data, software that learns from patterns, then we call that machine learning. And there's a little difference between data science and machine learning. Machine learning is usually done with how should I say that? No, machine learning is basically building apps that learn, and data science is basically the broader field of working with data, using statistics, using pattern matching, using learning algorithms on data. So machine learning is a subset of data science. Now, AI is what people talk about when they have no idea what they're talking about. So when the press is talking about machine learning, they call it AI. And when we talk about intelligent robots and the robot Armageddon and robots with guns shooting everybody, that's AI. And when we talk about machine learning, it's just software that we train on data to find patterns in data. So it's I read that somewhere, that if somebody says AI, it's usually a hint that that's not a technical person. So Konstantin, you say machine learning is a means to make an AI. Yeah, I'll go with that. That's a good definition. All right, let's kick this off. I'm going to start my screen sharing. Here we go. Quickly going to open the participant window and the chat window. Here we go. Just moving some windows around here. Okay, I got the chat window so I can see. And I let someone in. Vibhav. Vibhav? I think I pronounced your name correctly. Hi, welcome to the webinar, the live event, I'm sorry. We've already started, but feel free to catch up. No one else in the waiting room, awesome. So let's continue. Okay, so I got the chat window open. If you've got any questions, just type it, I'll see it right away and I'll answer. We'll also have a Q&A at the end, so you can ask me questions when I'm done. Okay, so here's a concept I use all the time when I talk about machine learning, the red ocean and the blue ocean. These are marketing terms, and they refer to like target markets when you're trying to sell a product. A red ocean is filled with competitors, so it's really hard to sell something. A blue ocean is completely empty, so you're the only person selling a specific product, and all the customers have to come to you to buy that product because there's no one else. So this also applies to software development jobs. If you're in IT, if you're in software development, then a red ocean is an ocean where there's a lot of competition. So that means you're doing web development, or you're doing mobile application development. I mean, these are fairly mature fields. There are many, many other developers who have the same specialty. So when you're trying to get a project or when you're trying to get a job, you'll have lots and lots of competition. Now, the blue ocean is if you're the only person with a certain specialty. So customers have to come to you because there's no one else who has that skill set, who has that specialty. I was in a blue ocean a couple of times in my career. I was a SQL Server consultant like a long time ago when SQL Server just started to get popular and started to overtake Oracle in customer adoption. And it was awesome, I had lots and lots of work. Later, I became a BizTalk trainer. So I gave classroom trainings on BizTalk, Microsoft's message orchestration software. And that was awesome too, because at that time, there were only 2 BizTalk trainers in all of the Netherlands, and I was one of them. So if any company wanted to attend a BizTalk training, they only had 2 choices, call me or call the other guy. So I had a steady stream of work. It was just fantastic. I could decide to do projects or not. I could say no. I could say, oh, I'll do this one. I won't do that one. It was just fantastic. So machine learning is the same thing, basically. Machine learning is a fairly unique skill. I mean, there's a lot of hype right now about AI and machine learning, but there are not a lot of software developers who can actually build machine learning apps. So it's becoming more and more popular. But right now, there's a big shortage on the market. There aren't enough machine learning developers right now. And companies really want to build machine learning software. So they're really looking for talent. So it's a blue ocean. So if you specialize in machine learning, you're going to have work. You're going to have lots of projects. You're going to have lots of jobs. People will come to you. You know, headhunters will call you. You'll be in a very comfortable position. So now is really a good moment to start learning about machine learning, to add that skill set to your repertoire. You know, because it will really help you with your career. And you have to be really careful, because as a software developer, it's really easy to get stuck in a red ocean. If you specialize in something and then you don't develop, then 10 years later, your specialty will be completely common. And you'll have competition, you have to drop your rates to even get work. It's not a fun position to be in. If you have a regular job, you know, on a payroll, then you have to worry about getting fired. If you get fired, I mean, who would hire you? Because there are 100 other people who can do what you can do. So I urge you to always look for a niche, look for a skill that is unique. It's not very popular, and it's in demand at the moment. And right now, that is machine learning. So if you look at the market, so here is the market, the AI market by year, separated into products, into different types of machine learning. So you can see the growth is pretty awesome. It's actually exponential growth, but we're in the starting bit first. So it looks linear, but after 2024, it really accelerates. So I've highlighted 2019, and you can see that everything is growing. Deep learning is growing, language processing is growing, machine vision, computer vision is growing. The entire market is just expanding and growing with you know, so many percent every year. So it's a great time to step into machine learning right now. A growing market means more and more companies building machine learning applications. Need machine learning software developers to build those apps for them. You know, so your job prospects just look awesome right now. And you can see for the next 5 years, it just keeps growing. The market will probably get saturated eventually, but we're at the start of the hype cycle right now. So you probably have at least 5 years and probably 7 to 10 years that you can coast along with a machine learning skill set before the market gets saturated and the whole thing turns into a red ocean again. So again, this is an awesome moment to get started. Oops. So if you're wondering, you know, if you're thinking machine learning sounds really complex, it's really complicated stuff, and you know, isn't that for academics or for professionals or like super smart people who earn 100,000 per year, you know, and they get scooped up by Google and Facebook and etc. Now, here's the interesting thing. The machine learning, the tools that we use to develop machine learning applications, they all had to be invented from scratch. And to do that, you need to be really smart. You need to have an academic background, probably a PhD in mathematics and computer science, decades of experience, you know, and these people have all been scooped up already. So they're working at Facebook, at Apple, at Google, and they're building all these amazing tools and libraries. But now we are entering a phase where these tools are readily available. So they're all out there. So if you want to do like speech recognition, you know, like you have these large neural networks that can do perfect speech recognition, you're not going to build that from scratch. And you don't need to be an academic expert on neural network topologies to build that. You know, you just Google it, and there are like a ton of libraries out of the box. You can do even the neural networks for speech recognition. You can just download the neural networks and run them on your system. So all the cool stuff has already been invented. Computer vision, tracking people, zeroing in on faces, recognizing emotions, analyzing satellite photos, finding patterns in data, you know, scanning revenue for the last year and then extrapolating what the revenue is going to be in the next 5 years. All that stuff is super easy because all the algorithms have been invented. They're all available in libraries. You can easily install the libraries. They're all NuGet packages, basically. So, you know, with a single line of code, you can add the package to your project and you can get started. So we're at a point now where you don't need to understand the nitty-gritty details of these algorithms. You only need to be able to use the algorithms to make a difference in the field of machine learning. Because take computer vision, for example. Computer vision is awesome, but not all low-hanging fruits has already been discovered in computer vision. So we can hook up a camera to a computer and write software, and the software sees the world through the camera, and it can process these camera frames, and it kind of understands what it's seeing. You know, that's pretty cool. But all the cool business apps that we can build with that technology haven't been invented yet. So we have the library, but we don't have the saturated market yet, where everything has already been done. I'll give you an example. There was a really cool app a while ago. Somebody invented an app that it was in a manufacturing plant for car seats. So this was like a giant machine in a factory that took a sheet of leather and basically folded it around the car seat. So it created car seats, basically. And these seats would then be shipped out to car factories to be inserted into different types of cars. And they had a guy checking if the machine did its job correctly. So sometimes the machine would exert too much force and the leather would rip, or it wouldn't be folded around the seat correctly, and there would be a crease on the seat. And then, you know, those seats were rejected. And they had a guy checking that visually. So there was a guy looking at car seats all day with a green and a red button, basically approving seats or rejecting seats. And somebody built an app to look at a car seat, and so the software understood what a correctly upholstered car seat looked like. And if the leather was all smooth and there were no creases, then the software would recognize that and it would approve the seat, and otherwise it would reject the seat if it zoomed in on a tear or a crease or, you know, a splotch on the leather or that kind of stuff. And it worked flawlessly. And it was an off-the-shelf computer vision component that did all the work. Basically just a computer vision neural network that was trained on car seats. And the technology behind that kind of app is super simple. I could teach you that in 6 weeks, basically. And you could build that app yourself. So what I'm trying to say is there is a lot of opportunity out there right now to build awesome machine learning applications and really, you know, build apps that people will love. And all the tools are already available. So you don't have to be an expert. So if you look at this slide, for example, if you're programming in C#, you know the language, you know a little bit about the compiler, you may be vaguely aware of how the .NET runtime environment works, but the layers below that, you don't understand that, and it's okay. You know, do you know how the hardware works? Do you know how a CPU works internally? Do you know 64-bit machine language, like the 8386 assembly codes that you know that machine learning consists of? That assembly language, sorry, consists of? You probably don't know assembly language. You don't need to know. You need to be an expert in C#. You need to understand the compiler up to a point, and you can be productive with that set of knowledge. And the same thing goes for machine learning. So here we go. So with machine learning, you need to know how to develop machine learning applications. You need to know the algorithms. So you need to know the data science algorithms, you know, regression, classification, how to build an ensemble, how to build a decision tree. You need to understand those algorithms. You need to know how to use these algorithms in a machine learning library. And that's it. And there are layers below that. There is there's matrix algebra below that. You need to understand a little bit of matrix algebra, but even if you don't, you can be productive. There's this cool library called CUDA, which is like a library for running machine learning apps on a GPU. You don't need to know how CUDA works. You don't need to know how a GPU works or how you can build one from individual transistors, you know? So there are these layers in the technology stack that you don't need to know, and yet you can still be productive. So this is what has changed recently. In the past, to be fluent in machine learning, you needed to understand the complete technology stack from top to bottom. And now we're entering an era where only the top layers are sufficient to be productive. And that's awesome because it opens up the field of machine learning to all software developers. And that moment is right now. So this is basically the core of my pitch. These trends basically mean that now is an absolute perfect moment to step into machine learning. And so you don't have to understand the entire technology stack to get up to speed. So you can use neural networks without actually understanding how a tensor library works, which is underneath the neural network running the whole thing, you know? It's basically a neural network compiler. You don't need to know how the compiler works. You just need to be able to use it. So what do you guys think so far? So am I convincing? In the meantime, I see a question from Chacho. How is machine learning applied into the renewable energy market? That's a good question. You probably have to find your own applications there. What comes to mind now, what I'm thinking of is like CO2 price prediction. So CO2 credits, and then, you know, the CO2 market is fairly complicated, very complex, with fairly chaotic price movements. So you could use a machine learning model to predict the price of CO2 and do smart CO2 trading based on that. One of the apps I want to develop is an app that monitors Brazil through satellite images and calculates how much rainforest they chopped down already. So basically a live rainforest tracker. Because you know, the Prime Minister of Brazil, Bolsonaro, is trying to shut down his environmental agency. So because, you know, he's destroying the rainforest and he doesn't want the rest of the world to know. So having a satellite aimed at Brazil and just calculating the whole thing and putting it on a public website, that would be an awesome product, you know. So there's a lot of stuff you can do, basically. Question from Konstantin. Wouldn't it be required to implement your own vector processing depending on your project needs? No, you can just use a library. You would use a commonly well, you would use a popular pre-existing library. For example, TensorFlow is the most popular library for running neural networks. It's just a giant tensor library. So what you call vector processing, you know, they call tensors. TensorFlow is just a giant tensor library, and you build your neural networks from individual tensors. You could build your own, but I would say use one of the pre-existing libraries. So, question from Matthews. How can we apply AI in digital marketing? That's a good question. You have to think creatively about that. I can give you an example. My social media is being run by an AI right now. So if you look at my Twitter feed, all my tweets, I don't type those myself. I use a neural network. I trained the neural network on my Twitter history. And then what the app does is it monitors a bunch of publications through RSS feeds. And then it runs these articles through the neural network. So it processes 10 to 20 articles per day. And the neural network basically predicts if the article is something that I would find interesting. And, you know, so if the neural network says, yeah, Mark would like this article, then there's a little zap that posts it on all my social media channels automatically. So, I mean, I have 7 channels. I'm on Twitter. I've got a couple of Facebook groups. I'm on LinkedIn. I have a LinkedIn company with a feed as well. So it's just too much time, you know. It took me hours and hours per week to keep everything up to date. So I just built an AI bot, basically, you know, a neural network, and it handles my complete social media for me. So that's a nice application of using AI in marketing. Other stuff you can do is analyze visitor behavior on your website. You could try and predict if people, leads in your funnel, what their total customer value would be. So just looking at their behavior, you could try to predict. You could say, this one, the total value will be $50. This person will be $1,000, I think, you know. So you could identify high potentials and then target your marketing campaigns at those high potentials. Macmillan, question, are there more Python ML jobs than C#? Because Python has been around longer for machine learning development. Yes, but that will change. So right now, there are more Python jobs available. Now that it's possible to develop C# machine learning applications, you can expect that the number of C# jobs will also go up. It's actually possible to develop machine learning applications in C# using the Python way of programming. That's really hardcore stuff. There's a library called TensorFlow.net, and it's a C# wrapper around TensorFlow. If you use it, you can build neural networks in C#, but you use the TensorFlow API, you use the TensorFlow style of application building, and basically your code looks a lot like Python. So it's like you're typing Python code, but it's actually C#. So this is a really cool project. I'm going to do a course on that. When you learn machine learning that way, using that library, then you're actually also learning how to do it in Python. The Python syntax would be slightly different, but it would be very easy to make that transition. So, you know, if you learn machine learning that way, you could actually transfer your C# skills directly to Python. But this library isn't done yet, so it's called TensorFlow.net, and it's still in active development. Once it's finalized, once we hit a 1.0 version, I'll make a course around it. So that's going to be one of my upcoming machine learning courses. Question from Konstantin: how important is speed for your machine learning programs? It's super important because you have to train your machine learning models. And if you're running on a slow platform, then training will take forever. And often you have to train an application for millions of training cycles before it starts recognizing the patterns. So a fast platform is a big advantage. And you said it in your question, Python is slow. Python is interpreted, and it's quite a slow platform. So you can expect C# machine learning implementations will be about twice as fast as Python implementations. So it's a big speed advantage. All right, there's this awesome library by Microsoft called ML.net, and it's been released. I think the version 1 was released a couple of weeks ago. I think 3 weeks ago, more or less. So this is brand new. This is Microsoft's go-to library for machine learning. They use it internally. So all the AI stuff in Azure and in Microsoft apps, it all runs on this ML.net library. So this is a C# library. So you can just tap into it with C#. All the APIs work beautifully in C#. And Microsoft really would very much like you to build machine learning apps with this. So it's been out for 3 weeks. I've actually got a course. I actually completed a course. It's called Data Science with C# and ML.net. I'll get to that in a minute, but I think this is the first course out there which covers ML.net, because this stuff is so new. And it's really awesome. You don't have to use TensorFlow, you don't have to use Python, you don't have to develop machine learning apps in this weird syntax that was invented by Google when they built TensorFlow. You can just use the C# way of development. So it's a pretty awesome library, and I encourage you to check it out. Question from Matthews: how can we apply AI and machine learning in statistical process control applications and inspection? Well, maybe risk assessment, for example. You could feed all the details of an industrial process into a machine learning model and let it calculate a risk profile. Maybe that would work. You could, I don't know, I'm not really an expert on process control, but maybe we call it this. If you run some kind of chemical reaction, the chemicals that you feed into the process, predicting the volume, how much do you need, ordering more on time, that kind of stuff, maybe. Best thing that comes to my mind is risk assessment. Question from Liso: what is the difference between ML and LUIS? So ML.net, this library is it's local. So you run it locally on your machine. Everything is local. You build your models locally. You train them locally. Nothing's in the cloud. LUIS is it's an API to build a conversational interface with an application. So you talk to an application. You say, hey, computer, book a meeting with Bob Friday at 2 p.m. at my favorite restaurant, And then the software receives that instruction, and it actually knows what I'm saying. It's like, oh, okay, you want me to make an appointment for you, and I need to contact this Bob person. So that's a conversational interface, and LUIS is a library for creating these conversational interfaces. And LUIS exists in the cloud, so it's an Azure library. So you let Azure handle the load for you. So I would say that ML.NET is a general purpose machine learning library, and LUIS is a library that's specialized for one task only, which is building conversational interfaces. ML.NET is locally, and LUIS is hosted in the cloud. Those are the differences. All right, so I've got this training program. It's called the Machine Learning Advantage. And a couple of you have done it, actually. So Phil, who's listening right now, he did it. And it was one large monolithic course. And I tried to teach everything in the course. So I started with data science, and then I introduced neural networks, and then we looked at advanced neural networks, crazy stuff like building generative adversarial networks and doing style transfer, making everything look like a Picasso. We built an object detector that could recognize dogs and cats. So you could point a camera at a dog, and the software would say, that's a dog, So we built all this crazy software. And at a certain point, I had this course. It was a 6-week program. And, it was just covering everything lightly. So it was like an introduction in data science, an introduction in neural networks, a quick look at computer vision, a quick look at cloud-based AI. And I wanted to add more content, but we were already at 6 weeks. And I could tell that at the end of the 6-week program, people were kind of exhausted. At the weekly calls, I could sense a certain tiredness in my students, because 6 weeks is a long time to go through a course. Yet I wanted to expand my course. So what I decided to do is to chop the whole thing in 4 parts. So Machine Learning Advantage used to be one course, but now it's 4 courses, and they each cover one specific topic. So the whole data science part, which was just a very quick introduction in the old machine learning course, now it's a separate course. And it's actually done. You can actually sign up right now if you like. So it's called Data Science with C# and ML.NET. So it covers like a whole foundation in data science. So it's linear regression, binary classification, multi-class classification, decision trees, bagging, boosting, stacking, clustering, recommendation systems, anyway, loads of stuff. So it's like this big introduction in data science. You'll be a data scientist when you complete this thing. So it's a 6-week program, and it just takes you through the whole data science curriculum. So this was like 4 lessons in the old course, and now it's a 6-week program, which only covers data science. And I'm going to do that for everything. So data science is done. That course is out there. It's published. The next one will be deep learning with C# and CNTK. So I'm still looking at how to develop that course, but the idea is to expand it into 6 weeks, and it only covers neural networks. So we'll start with neural networks, and we'll end with neural networks, and we'll do all kinds of crazy stuff. There will be a course about computer vision, and we will only do computer vision, like head tracking, full body tracking, object and motion tracking, emotion recognition, analyzing satellite photos, building burglar alarms that can track people with cameras. You could build a killer robot if you want, based on what you learn in that course. So it'll only deal with computer vision. And the final course will be about cloud AI. So I'll only be talking about Azure and how you can train these massive neural networks in Azure, with terabytes of data, and you can build these huge systems. You can do perfect speech recognition, speaker-independent speech recognition, conversational interfaces, really, really good object detection. I've got an app where it's trained on 200,000 celebrities. So if you're at a party, you can just take out your phone and you could just sweep the room with your camera, and the computer will highlight all celebrities in the audience. So if Elon Musk is hiding somewhere in the crowd, and it will just highlight him right away. So it's a gigantic neural network trained on 200,000 faces. So we'll use that in one of the apps. So that's Cloud AI. So this is the whole program. So it's 4 courses, and each course really zooms in on a single subject. And if you add everything together, it's 6 months. So, this whole program is half a year, and you're basically a full-blown expert in machine learning and computer vision and data science, the works. So this is how I solved my problem with my course. you know, chop it up into 4 parts. So if you like to check it out, the URL at the bottom, machinelearningadvantage.com, will take you to a nice, a beautiful landing page. The first course that I released so far is the one on the left, Data Science with C# and ML.NET. And the next class starts on September 16th. So it's kind of a live class. I mean, it's a traditional course. You can just sign up for the course and go through the material yourself. But I host weekly calls, weekly video calls. So I basically guide you through the material. So these are like 1-hour calls, and we just talk about the topics for that particular week. So it's kind of like a hybrid do-it-yourself course or a guided course. You can basically pick how you want to do it. So check it out if you're interested. It's pretty cool. Let me quickly look at the chat window. How can I train and make a model for inspection application? Application like production inspection or quality inspection. I need a bit more info on that. Let me know in the chat what you are trying to inspect. Is it like optical? Are you like filming something with a camera and need to inspect that? Is it data? What are you specifically inspecting? Okay, any questions so far? What do you think so far? Are you pumped about machine learning? How many of you are C# developers actually? Like put a yes on or a C# in the chat if you're a C# developer. If you're not a C# developer, put the language that you are a developer in the chat. So Lisa and Macmillan are C#, Konstantin, C++, respect, nice work. So anyone else? What are you developing in? Bruce, C# developer, nice. Matthews, C#, Vrax as a hobby, cool hobby, man, nice. So anyone else? Any Python developers in this group? Any JavaScript? Who isn't a developer? Like if you're not a developer at all. Macmillan, some experience with Python. Yeah, me too. I can write short apps in Python, but I'm not an expert. All right, so it looks like we're all developers. Awesome. Millen, C#, nice. So mostly C#. So Konstantin, C++ is pretty awesome. The syntax is pretty much the same. If you know the C++ syntax, you'll know C#. C# and Java are very similar too. C# is like a better version of Java, but any Java developers who hear this right now are going to hate me for saying that. For you, it will be pretty easy to develop in C# because it's this might surprise you, but performance-wise, C# and C++ are very, very close together. If you optimize the hell out of a C# application, you get really close to C++ performance, optimized performance. C++ is roughly 5% faster than C#, so 5% difference. So people underestimate the language a lot. A lot of people think that C# is really slow and it's interpreted, but it's not true. It's very, very close to C++ performance. All right, so who wants to see me build an application with C# and ML.NET? You guys want to see a code demo? All right, Rax, let's do this. Lisa, let's do this. Macmillan, yes. Konstantin, yes. Phil, yes. You want to see a code demo? Phil, but don't you know all this stuff already? But you haven't seen ML.NET yet, of course. So Phil has been working with CNTK in one of my courses, the Cognitive Toolkit. He's been building neural networks using CNTK. And that's pretty awesome stuff, really hardcore stuff. It's built some really crazy apps. So I hope this is as exciting as the stuff you've done already. No, I'm kidding, you'll enjoy it. All right, so I am going to develop in .NET Core, because this is another, yeah, it's the VS Code editor, Millen, that's correct. I've got another philosophy with these demos. I want you to be able to run this stuff on your laptop, regardless of the OS that you're using. So this, right now, this is a Surface Book 2. I recently bought a new laptop. This is a fully kitted out Surface Book 2, the largest edition. So it's a pretty awesome machine, but before I had a MacBook Pro. In fact, I still have it, it's in my living room. I've got a Mac and I've got this Surface Book 2 running Windows 10. And I want the software to be able to run on any OS. So if you have Linux, fine. If you have Windows 10, that's awesome. If you have a Mac, that's awesome too. So all my code is specifically developed on .NET Core version 3, which is the multi-platform version of .NET. So out of the box, it'll run on all these 3 operating systems. I also use Visual Studio Code, so not the regular Visual Studio, but Visual Studio Code, because it's also available on all 3 platforms. You got a Linux version, you got a Mac version, and you got a Windows version. So you can literally replicate my development environment regardless of the OS you're using. And this is a big plus, because in the past, like my old machine learning course, it used Visual Studio 2017 and Windows 10, and so a couple of people had to run it on a virtual machine. They had to, install it on a VM, and that's just annoying. You don't want to do a course in a VM. I mean, you can, but it's just a lot of work. So I do everything in .NET Core. So this is really, really cool stuff. Okay, quick question from Matthews, actually from Bibin, who's using Matthew's session. How can we improve the profitability of an e-commerce website using AI? Well, predict customer behavior. If a customer orders a product in your web shop, use machine learning to predict if this customer would be interested in an upsell or a cross-sell. And then use that information to target upsells or cross-sells to that customer. Obvious example is if I log into your web shop and I order a vacuum cleaner, then obviously you'll be able to sell me accessories, you'll be able to sell me vacuum cleaner bags, spare bags, but maybe other cleaning products as well. So you could easily train a neural network to understand product relationships, like people who bought this will probably also buy this. That's called a recommendation system. And then you use the output of that recommendation system to target ads to your existing customers. And you'll see a really high conversion rate on that. If you want to build a recommendation system, it's in the course. It's in the data science course. We have an Amazon data set with 1 million product combinations from Amazon. And we train a recommender on that. And then the system will start recommending product combinations. I think we also do it for movies. So I've got a movie database with, I think, 8 million movies, really large. And then one of the assignments is I give you 2 or 3 movies that I like, and then you have to predict which other movies I would probably enjoy. You have to build a recommender to make that prediction. So I'd say start with that. Product recommendations, and then target cross-sells and upsells. Okay, let me show you this beautiful console. So this is the Windows Terminal, the beta version, the new Windows Terminal. It's pretty nice, actually. This is PowerShell, bit pimped up, but it's basically PowerShell. I'll show you the .NET environment. So here's my .NET environment. So you can see I'm running Windows 10, 64-bit, and I'm using the .NET Core SDK Preview 8, version 3, Preview 8. So it's almost released. We're almost at the 1.0. Well, we're almost at the release version of 3.0. But this is Preview 8. It's feature complete, and they're just debugging it as we speak. So the next release will be the official release for 3.0. So this is my .NET SDK. I'll do a lot on the command line. I'll show you Visual Studio Code, and we can walk through the code. So here's Visual Studio Code with my application. And so this will run on any OS. So my application is actually super simple. I've got a database. Let's see if I can show it to you. This one. Let's see if it loads. Yeah. Ah, there we go, it loads. Unfortunately, I need to be at the start of this file. I'll do it differently. I'll just show you the head. So here's my data file. So you can actually download this data file yourself. The New York taxi companies, they have an oversight organization that basically tracks all their rates and makes sure that there's no unfair competition. And they publish their data files on the internet, on their website. And you can just go there and download the info yourself. So this is from, I think, yeah, it's from December 2018. So this is 1 month of taxi data. And every line is an individual taxi trip. So these are like thousands and thousands and thousands of trips in New York, with all the details, how many passengers, the date and time when they did the pickup and the drop off, if there is a special rate, like if you go to JFK Airport, you pay an elevated rate, how you pay at the end, if you pay with cash, with credit cards, and all these factors determine the fare, the final fare. So this app takes this file, this data file, and it trains on this file, and then it is able to predict any taxi fare. You can just enter data and it will make a perfect prediction. So I'll show you the code. So when you're working with ML.NET, so the only thing you need to do is just basically pull in the NuGet package. It's a package called Microsoft.nl. That's the whole machine learning library. And then you add these using statements to your code, and you can get started. The first thing you need a data class that represents one record in your data file. So here it's called taxi trip. And you can see these are the columns that I will work with. So I've got vendor ID, the taxi company. I've got the rate code. So like 1 is standard fare, 2 is JFK Airport, 3 is something else, and so on and so on. I've got the number of passengers in the taxi. I've got the distance in miles. I've got the payment type. 1 is credit card, 2 is cash, 3 is Visa, and so on and so on. And the final field is fare amount. So fare amount is how much the passenger paid in the end. The load column attributes that you see there are where to find that column in the CSV file. So these are like little attributes that help the data loading codes to know where that column is located. So I can just pick out the columns that I'm going to use from the data file and ignore the rest. Now I need another class called fare prediction. This will be my prediction. So when I ask the fully trained model to predict the price of a taxi fare, it will return this class. And this class just has fare amount, and that's the prediction. So the model is basically saying, okay, Mark, you're traveling 4 miles in New York and you pay by credit card. It was just you in the taxi. So it should be about $16, and then the value of 16 will be in that fare amount field. So then to get started, so here's how you get started. So the first thing you would do is you would create a text loader. So a text loader is just a class that describes how to load data. So this text loader is going to load a CSV file. And you can see that I've highlighted the different columns and the data types. So these are like the data types of the type, how to convert the data. So you can see that I'm converting some fields to single and some fields I leave them as strings. And then to load, the only thing you need is this single line. So calling the load method on the text loader class will just load the whole thing in memory. So it doesn't actually pull everything in memory. It's a lazy loading mechanism. It sets up a loader, and then with a forward-only mechanism, it goes through the whole file record by record. So you can load gigantic files with this mechanism. You can have a data file of 1 terabyte and use this code to go through the whole thing. It'll take forever to process, but it's not copying everything in memory and then processing it in memory. So ML.NET is really optimized for very large data sets. So then there's a little trick I'm doing here. This is something that comes back in the course. To reliably work with data science models, we usually train on part of the data, and then we test the trained model on another bit of the data. So we basically create 2 partitions, and we have 1 partition for training and 1 partition for testing. And that's what this line does. It just chops the whole thing in half, and it reserves 80% for training and 20% for testing. So then, to get started, everything in ML.NET is a pipeline. So if you want to build a model, you always start with a pipeline. And the pipeline begins with loading the data. or basically pulling in the loaded data record by record, and then you can add all kinds of transformation stages, data transformation stages, and at the end you would put a learning algorithm that tries to find the patterns in the data. So in this case, you can see here I'm building a pipeline, and the first step that I'm doing is I am copying a column. So this is kind of weird. I'm taking a column and just making a copy. So I've got this column called fare amounts, and I'm copying it into a new column called label. So you can do that. You can just copy a column and create clones. Then I'm using a little trick here called one-hot encoding. Again, this is from the course. I won't go into it in too much detail. One-hot encoding is a pre-processing step that we have to do in data science when creating machine learning models when we work with enumerations. So like, for example, the payment type, 1 is MasterCard, 2 is cash, 3 is Visa card, 4 is Amex. If you have that kind of data in your file, then you would use this trick called one-hot encoding. It helps a machine learning algorithm to learn on that data. So I've got a bunch of one-hot encoding steps. Then I do this concatenate step. This is a little the detail of the ML.NET library. ML.NET can only train on a single column. So if you want to train on 20 columns, you can't do it. So what you would do is you would combine those 20 columns in one large hybrid column and then train on that large thing. So that's what's happening here. I'm taking these columns, vendor, rate, passenger count, trip distance, payment type, and I'm adding them all together, mashing them all together in one new column called features. So, features is just all the other data, added together. It just streams all the data together. So then I have this single feature column, and then I can train on it. So the training happens here. So I'm appending this regression step, the regression trainer called FastTree. So FastTree will build a decision tree, which is a specific kind of data science algorithm. And the tree will learn to recognize the patterns in this data. And of course, the pattern is the fare. It will try to predict the fare amount based on all these other input variables. So like if I pay with a MasterCard, does the rate go up or down? If I travel to JFK, is it more expensive or cheaper? If I travel with 4 people, is the rate higher or lower? All these little details, all these little patterns in the data, it will learn these patterns. So then if you want to train your model using this pipeline, here's how you do it. So you simply call the fit method on the pipeline, and you provide the partition that you want to train on. So in this case, I have this 80% that I reserved for training, and I call fit on that data, and then I get back something called a model, and this is the fully trained machine learning model. So now I have a model that can make predictions. So the first thing I do here is this is a little test to see if the model actually makes sense. I take my other partition, the test partition, and I ask my model to make predictions on that data. So basically, the model's going to train on 80% of all the fares, and then it will use that trained model to make predictions for the 20% remaining of the data. And then I can do a really cool thing. I can take the actual data in this 20% partition and compare that to the predictions. So I've got the prediction that my model is making, and I've got the actual taxi fares, and I can compare those two. I can see, okay, how accurate is my model? Is it wrong all the time? Is it correct all the time? And what's the accuracy? So that's what this code does here, this evaluate code. So evaluate compares the actual data with the predictions, and it returns this class called metrics. And this metrics class it contains a bunch of interesting KPIs, interesting variables that I can show to see how accurate the model is. So here's a variable, and I'm printing. It's called root mean squared error. Root mean squared error. So we often abbreviate this to RMSE. RMSE is a number that indicates how good the predictions are. And if the RMSE is 0, that means the predictions are perfect. Every prediction exactly matches the actual fare. So you always want to get your RMSE to 0. And if it's non-zero, the higher the number, the larger the number, the worse your predictions are. The disadvantage of RMSE is that it doesn't mean anything, it's just a number. So we have another metric here called mean absolute error, and this is the average mistake in dollars. So when this model makes a prediction, the prediction will be off by so many cents or so many dollars, and that's what this value means. It's the average mistake in individual predictions. So it's not the same as RMSE, it's a slightly different scale, but the nice thing about this metric is that we can express it in dollars. So I could say, you know, I predict the trip is $16 and the error in this prediction is plus or minus 20 cents, you know, and the 20 cents, I would pull that value from this variable. So this is really cool. I get these metrics that I can use to see how accurate my predictions are. And then the next step is, if I want to make individual predictions, I need to create something called a prediction engine. So this create prediction engine method, it creates an engine that can make individual predictions. So I can throw in a single taxi trip and it will make a prediction for that single trip. So here's a taxi trip. So this is me. I'm in New York. I'm making a trip. So it's standard rate. I'm not going to JFK. I'm just point to point in New York. I'm traveling 3.75 miles. It's just me in the taxi cab, and I will pay with my credit card, with my MasterCard. So that's the data in this taxi trip sample. And then this line of code right here, it predicts what the fare should be. So it creates this prediction class, and the prediction class, you saw it at the top of the code. It's this taxi trip fare prediction thing, you know, with this single field that will contain the prediction. So now I have my prediction and I can just show it. Now I know actually that the fare should be 15.5, so $15.50. So we can take a look at the model and see what the model predicts for this trip. And this is how you would use your fully trained model in your own apps. You would create a prediction engine, throw in the data, and then create predictions, and then, you know, compare the predictions to what the values should be. Or if you don't know the actual values, just work with the predictions themselves. The training, we only do that once. So we train a model once, and then we just use it over and over again to create predictions. So you want to see this run? That's all the code. It's pretty simple, huh? It's like 148 lines of code. Shall I run it? Yeah, you want to see it run. So thank you, Konstantin. I was just waiting for a yes, you know. There's somebody to say yes. So here's the thing. I'm going to run it on the console. So so this is a PowerShell console. You can see I'm in the I'm in my project directory. So I can do a list of files here. So you can see this. You can see the program.cs. You can see the CSPROI file. You can see the CSV file. So you can see I've got 8 megabytes of data. The actual file, the actual taxi file, is actually 688 megabytes. So that's the full version. It takes about 60 seconds to train on that full data. It'll be a lot slower because I've got Zoom running right now. So I'm going to demo this with a smaller file, 100,000 trips. And you can see it's 8.4 megabytes. So that'll go a lot faster. So to run this, the only thing I need to do is .NET run. So this will run the .NET application on the console. This is the C# console app, super simple. So this will run on any operating system. So let's see if this works. You always have the demo effect. You never know if it's going to work in a demo. There we go. So check this out. So it trained on 100,000 taxi trips. It took 3.8 seconds to fully train the model. So it's fairly quick. You can see the metrics here. So the RMSE is 3.6, which it's not 0, but it's not very high, you know. So probably okay, maybe. But the mean absolute error, MAE value, below is much more useful in this case. It's 1.26, which means that on average, predictions will be off by $1.26. So that's not bad, right? So this is an app out of the box that can make taxi fare predictions, and it's off by slightly over $1. So not bad at all. So you could build your own mobile phone app. You know, you're taking a trip in New York, and your phone uses GPS to track the trip. And then at the end, the taxi driver says, you know, that'll be $34. And your app will say, no, that should be $12. You know, haha, you're trying to fleece me. So you can build an app to protect you from taxi scams based on this code, 100 lines of code. My single prediction, so you can see the predicted fare is $14.75, and the actual fare is $15.50. So we're off by slightly less than $1. So you can see that the MAE value is spot on, right? The average error is slightly over $1, and in my single prediction, I'm slightly below $1. So that kind of makes sense. So Macmillan, you say cool stuff. I also love your idea about monitoring the destruction of the Brazilian rainforest and making it public. I am planning on adding that to the computer vision course. So that will be an assignment in the computer vision course. So, you know, everybody who signs up for the course will literally do that. So we can troll Brazil with this, you know, and you know, they can try to shut down their environmental agency, but we software developers can work around that. So it's a cool thing. So Vrax, how about the RMSE if you use the full data set? It would be lower, obviously. I can change the code and do a run. I'll save that until the end. Let me continue with my final things, and then I'll do a full run at the end, and you can see if the RMSE is lower. It's not a guarantee. Huh? The longer you train, the lower the error gets. That's what you would expect. But at a certain point, it levels off. The error will level off, and you can train longer and longer and longer with more and more data, but your error will remain constant. And there's even a risk called overfitting. In certain scenarios, the longer you train, the larger the error gets. So basically your algorithm goes completely out of control. So you have to be very careful about how much data you use and how long you train. So Phil, the ML.NET API seems really clean. I like it. Yeah, it's pretty awesome. Huh? Just pipelines and then fit, evaluate. You create a prediction engine. It's like super short. Really, really nice stuff. Okay, now prepare to have your mind blown. I'm actually running Linux on this computer as well. I've installed the Windows subsystem for Linux, which is it's a lightweight virtual machine. It's part of Windows. It uses the Hyper-V hypervisor that's built into Windows, and it runs an unmodified Ubuntu kernel. So I've got Ubuntu version 18, the entire Linux kernel running unmodified in this virtual machine. And I've got it right here in this beautiful terminal. So here is the directory that I'm in right now. So you can see it's the same directory. The Windows file system has been mounted in this folder called C in the Linux file system. So I'm working on the NTFS file system right now, but from within an Ubuntu Linux kernel. Now let me quickly fire up the .NET command. So, whoops, guess I made a typo. Can't exactly see what I'm typing. Did I make a typo? Oh, yeah. My console was hidden underneath a pop-up window. Here we go. So here's the .NET SDK version 3 preview 8 for Linux. Literally the Linux version. There's nothing Windowsy about this one. You're looking at the literal Linux toolchain for .NET. It reports the operating system as Ubuntu, version 18.04. The platform is Linux. So we're running on the Linux kernel, basically. And I'm going to run the same app. You can see what I like about PowerShell is that it uses the same commands as Linux. It has aliases for Linux, so I can type ls and pvd and clear, and they will work regardless of in which tab I'm working. So one thing I do need to do is .NET build. I need to quickly recompile everything for Linux, because otherwise it would try to run the Windows binaries in Linux, and I would get really weird results. So I'm recompiling now. There we go. So now the bin folder, all the contents of the bin folder has been replaced. The Windows stuff is gone, and it's replaced with Linux binaries. And now I will run the app. So this is the same application, the same source code, but I'm running it on Ubuntu. So training the model, 3.9 seconds training time. And there are the results. So RMSE of 3.6, mean absolute error of 1.26, fair prediction 14.75, actual fair 15.5. See, same results. So you could do this on a Linux laptop directly. Or you could, install Linux on top of Windows, like I've done here, and then, run it on Linux or on Windows. But you can see it's just console. It's a console application in C#. The operating system doesn't matter. It'll just run. I haven't got my Mac with me. It's in the living room. But if I had my Mac, I could show you this on the Mac as well. It would just work. So really cool. Multi-platform machine learning with .NET Core. So that's my demo. Okay, so I will answer your request. I'll very quickly edit my application. And let me remove this, give myself a bit more room. So there you go, full version. So this is the full version with 8 million taxi trips, 8 million. So I ran this earlier today and it took 60 seconds. Let's see what result I get now. So I'll run it in PowerShell. So do a quick recompile to replace the Linux binaries and put the Windows binaries back. Here we go. Now, I hope I typed the file name correctly, but we're going to find out really soon. Did I type the file name correctly? Sure, I did. You can see loading trading data finishes immediately. So that's a clear hint that it's not loading it into memory. It's just preparing stuff, It's preparing a CSV reader. And when I train, then it pulls in the data record by record and trains on it right away. Okay, while we're waiting, it's going to take a while. I'll look at the chat. So Liso, you said, if I understand correctly, this requires for you to have data to use in ANML.NET. Can you use it with customer experience or FAQ? Yes, you can use any kind of data. So it can be numbers, can be text, anything you like. So if you have FAQ, if you have text and you want to train on that, you can do that. If you have customer experience in form of report results, survey results, questionnaire results, you can train on that too. So text and numbers, basically. So yeah, that'll work. Constantine, can we expect similar goodies for Visual C++? You can just call this library from C++. I mean, you would have to use managed C++ and then just call the methods. That'll work. So are you familiar with managed C++? So calling .NET code from C++? It's a bunch of extensions that will allow you to call managed code directly from C++. Kind of, yes, yeah. So that'll work. Just enable managed C++ for your project and then pull in the package, the NuGet package, and then you just call it directly. That'll work. Matthews, will it be possible to find the best price of a product that will give the maximum profitability? Yes. For example, to attain maximum profit, we should have a trade-off between the price of the product and the product sold. If we can find this trade-off, we'll be able to maximize the profit. Can AI be used to create something like that? Yes, absolutely. Absolutely. You just need the data. If you have the data, you can train on it, and the AI will find the pattern for you. Absolutely. I'm just going to scroll back through the chat window to see if I can find older questions that I hadn't answered yet. Or, you know what, if I haven't answered your question yet, just type it again in the chat window. Constantine, is there a future for ML in game development? Better NPCs. How about that? NPCs that don't suck. So you're in collaborative team mode, you're doing a first-person shooter, and your team buddies are AIs. And they make sensible decisions. So you're probably going to see that first. There's a lot of C# developments in the gaming sphere around Unity. Unity is a really nice gaming platform. You can build games in C#. What's very popular right now is to build NPCs driven by AI. So, non-playable characters that are controlled by AI. Here we go. So the, look at that. So here, see, the RMSE actually went up. So I trained on a larger data file, and now the RMSE is 58. So the results actually got worse while I was using more data. So that's very interesting. We would need to analyze this a bit more and see exactly what's going on. So it makes sense. I trained on 100,000 records, and my model had a fairly accurate prediction. But now I'm showing it the full data, And it turns out that the actual taxi fares are much more complicated than the model expected, and it cannot do such a good job. If you look at MAE, I'm now off by $2.12. So my error doubled. So it means that in reality, this is a realistic accuracy. You would be off by $2 if you train on the full spectrum of data. And I kind of cheated by only looking at a small subset of the data, and my subset did not include certain patterns. So my model was too optimistic. So pretty awesome, huh? It's quite surprising. So you can really get caught off guard in machine learning and data science. Partitioning your data, processing your data, having the right amount of data, picking the right learning algorithm, all that stuff is super, super, super important. Okay, question by Bruce. What type of data would be used for images and handwriting recognition? Well, images, it's pictures. We would store the images in a folder. So we would have a folder with thousands and thousands of images. And then the loading code would take an image and just look at the pixels. So it would take the image apart and put all the pixels in a long row. And you would get this vector with like a couple of million numbers in it. And these would be the individual pixels. And then you use special algorithms to process those images. Usually, when you process images, you train a convolutional neural network. Convolutional neural network, or CNN. It's an optimized algorithm for recognizing images. Liso, while rerunning the app to go through the training again help, or some more refactoring? Will rerunning the app help, or some more refactoring needed? Okay, let's run it again. We can see what happens. We'll see if we get a different number. Refactoring is necessary in this case. But even though $2 is pretty good, huh? It's not bad actually. So the fair price is $15. It's off. The model is off by $2. Training on 8 million records. Every single trip in New York for the whole year. It's not bad. Maybe $2 is actually a good result. But you could certainly do some refactoring. I'm using a fast tree learning algorithm to train on this data. Maybe a different algorithm would get better results. So there's room for experimentation. So this will take another 147 seconds. So you can see it's a bit slow. It takes 60 seconds if the laptop is not doing anything. But now with the Zoom software running, recording the desktop, it's going to be a bit slow. So we'll just wait for the results and see what happens. So it's quite possible that we see something different now. The machine learning models are initialized with random numbers. And quite often when you do a training run, the model does not discover the best possible solution. It gets stuck in a false solution. We call that a false minimum. So then the model thinks it's done training and it found the best possible configuration, but it's actually stuck in a suboptimal configuration. And then the best way to get the model out, and to see the full spectrum again, is to just run the training again. So you would typically train a model a couple of times and see if you get different results every time. So let's see what happens. Let's look at the MAE, the mean absolute error, on the second run and see if we get a comparable result. So if you have any other questions, put them in the chat. Got my chat pop-up right there. You can see everything. So if you asked me a question earlier and I did not reply yet, did not respond yet to the question, just copy and paste it and put it back in so I can see it at the bottom. I'll get down to it. 112 seconds. Not bad. So now it's running evaluation, 20% of 8 million. So it's quite a long evaluation. There we go. See the same MAE. So we still have 2.12. RMSE is the same, 58.95. So this is the best possible result for the data file, given the code that I'm using right now. So to answer your question, yes, we need to refactor. Liso, question from Liso. A bot used on e-commerce sites will have a lot of different questions. How can ML be used in this case? You need a conversational interface. So this is actually really hard. Machine learning models, to understand English text and to receive a prompt, a question, and give the right answer, They're only just being developed. There is this new type of neural network called a transformer. It was invented by Google, I think 1-2 years ago, so it's really bleeding edge technology. Transformers are basically the first type of neural network that can generate useful answers. Like you ask something and you actually get a result that makes sense. So this is bleeding edge technology. If you look at bot libraries, bot frameworks, the technology used in those is usually quite primitive. It's usually if then else rules. Like the library looks for certain keywords in your question and then creates a response out of that. This is why most conversational interfaces tend to suck. The best we have right now is Google. You say, hey, Google, and you ask Google a question. That single sentence works quite well. So you ask a question and Google answers. It's a massive neural network that does that. But then if you ask another question, Google will have forgotten the first question. So it's not really a conversation. You're just issuing instructions to Google and Google is executing them for you. But you can't really string a sentence along. Like, hey, Google, what's the most popular movie right now, in the cinemas? And Google says, well, that's, I don't know, like The Avengers. And then you say, okay, book me a ticket. And then, Google has to connect those two. It's like, book me a ticket for The Avengers, which I mentioned in the previous sentence. That doesn't really work yet. The transformer neural networks are kind of starting to grasp that kind of challenge, but this is all fairly new. So for e-commerce, for bots, you would use a traditional bot framework like LUIS, the LUIS API in Azure that can run a conversation for you, that can do a conversational interface. It's in my course. One of the assignments in my Cloud AI course is we build a bot that handles schedules. So you could say, hey, computer, book me an appointment with Bob, book me an appointment with Phil, book me an appointment with Phil on Friday at 2 p.m. And then it would just do it. So yeah, you wouldn't use data science for that. Anything else? So what do you guys think? It's pretty cool stuff, right? I mean, I picked this demo, the taxi fare prediction, because it's something you can relate to, the making sure that you don't get scammed in a taxi. But you could use this for any kind of data. You could do temperature predictions, throw in historic temperatures. What's the temperature going to be in 40 days from now? You could train a model to make those predictions. We could do the Brazil thing. We have a satellite photo of Brazil. We feed it into a model, and the model says, I have identified 6 million pixels that are rainforests, and all the other pixels in the image are not rainforests. And then we could just relate, we could take that pixel surface, calculate that back to square meters or square feet, and then we know how much rainforest gets burnt every year. You could do power estimation. If you have a smart electricity meter, you could look at your electricity usage over the last year, and then use that data to predict what your electricity usage is going to be moving forward. So you could do power estimations for your home. And that's really useful if you have, for example, a solar panel on your roof. You could combine a solar panel with a Tesla power pack, and then combine that with a smart electricity meter, and you combine those three things, and you could enable the power pack at moments when it's useful. The model would start to learn, for example, that you drive a Tesla car and you tend to arrive home at 6 p.m. and then you plug your Tesla into the mains to recharge the battery. So your home would start to learn those patterns, and it would reconfigure the electricity of your home to charge the car at 6 p.m. Stuff like that. I mean, the Nest thermostat, it's a simple machine learning model. It looks at the temperature that you set, and it tracks your habits, and then it just executes them for you. So it's like, okay, you leave for work at 8 a.m. in the morning, so that means shut down the heating, and you tend to arrive back home at 7:30 p.m. So I need to switch on the heating at 6, so that at 7:30 the house is nice and warm, for example. And I only need to do this in the winter and not in the summer. So the Nest thermostat is learning that from your actual temperature settings. Super simple. You could use a decision tree for that, or an algorithm called stochastic gradient descent, out of the box learning algorithm. It would pick up on these patterns. So Liso, you say, I really enjoyed this event. Thanks a lot, Mark. This event, it's not a webinar, it's an event. So Macmillan, very cool. Rax, interesting stuff. You guys have any final questions before I wrap this up? Let me quickly go back to the presentation. One of these things is my presentation. I don't know which one. Dropped me out of the presentation. There we go. Have any final questions? Liso, are you going to share the project? It's in my course. If you join the course, you'll get the full source code. And Bruce, would you have to go through the data loading and training every time you start a new session? Or can you save the trained matrix, quote unquote, for future faster loading sessions? Yes, you can load and save. So the model, internally, the model is a bunch of configuration data. It's lots and lots and lots of config values, millions of floating point numbers. You can just save those to a data file. And then you can take an empty model, you can load the data file, and then you have the fully trained model back. So it's a really popular way of working. If you do computer vision, if you build apps that can recognize dogs or cats, it's very, very common to take an empty neural network and then load it from a config file. And we have these pre-trained configuration files, massive files, like 500 megabytes, 800 megabytes, gigantic neural networks. And they were trained on industrial hardware, like grids of GPUs. They were trained on millions and millions and millions of images, and we can just use them. So there's this famous neural network called ResNet, and it won an AI challenge like 6 or 7 years ago, and it's available as a config file. You can just load the file. So you can take this ResNet neural network, which scientists have trained for us. It's all ready. We can load it into an empty neural network, then we get the full neural network, and then we can just show it images, like, is this a dog? Yes. Is this a giraffe? What kind of animal is this? It's an elephant. Oh, thank you. So, it's been trained on 1,000 different things, people, objects, animals, patterns, and it can recognize them out of the box. So this is really awesome. This is what accelerated computer vision, that we software developers could just instantiate these industrial size neural networks and add them to our code. So that's in my computer vision course. We'll be using some of these off-the-shelf neural networks. And Phil has actually done this assignment already. So Phil, he built a dog and cat detector, and we used a convolutional neural network called VGG16. And I think it's about 10 years old. It won a famous AI challenge 10 years ago. It has 3.5 million parameters. So really cool. Macmillan, will the Terminator really happen? If you go to my Twitter, I've got this post of a robot, a Russian robot. It's called Fedor. It's really cool, like a humanized robot. And the builders, they were pranking everybody, basically. They gave the robot 2 guns and they put it on a target range and programmed it to shoot at targets. So you see this humanoid robot, with 2 arms and 2 legs and a head, and with a gun in each hand, and it's shooting at targets at the target range. It's hilarious. Will it ever happen? No. The reason why is in the Terminator, there is one AI that decides to wipe out all of humanity, and it's all of us plucky humans against the single evil AI. By the time the AIs get antagonistic, which will probably happen eventually, by that time we will have millions of AIs. And we will have AIs that hate humans, we will have AIs that don't really care about humans, and we have AIs that think that humans are great and the best thing since sliced bread. So by the time the first AI-human war breaks out, there will be humans and AIs on one side, and there will be humans and AIs on the other side, fighting each other. And it will basically just be a normal war. So that's pretty much what's going to happen, according to me. So Vrax, you saw my post on LinkedIn. That's cool. Huh? I mean, that's so funny. They were just trolling us. I mean, there was a guy remotely controlling the robots, So they knew this was going to get clicks. That robot, by the way, they launched it in a Soyuz space capsule. It's on the way to the International Space Station. So the robot is being deployed in space, a Russian robot, and they're going to use it to, when astronauts do a spacewalk, the robot will assist them. So the robot will be outside and can help with mounting solar panels and doing repairs. So it's pretty cool. So a robot with gun training is now in space. What could possibly go wrong? Okay. Any other questions? Let me quickly scroll through the chat. No, I think I covered everything, right? Last chance. I'll give you 10 seconds to think up of a question, and then I'll wrap this up. Nothing more? All right, let's wrap this up. See, I've been talking for 90 minutes again. I wasn't able to keep it to 60 minutes. I always go over my time. Anyway, thank you for watching. I'm doing a whole series of webinars, so I'll do another one next week. It'll be a free training. I'll really dive into ML.NET, and I'll give you a free ML.NET training of an hour. I hope I will be able to push it in an hour. So next week on Thursday, I think I'll do it. So if you're interested, keep an eye on your inbox. I'll send you another email about it, and feel free to join. Check out the courses. The data science course is open. You can join right now if you like. And it will start on the 16th of September. And then we'll do this, it'll be a guided training, basically, with video sessions with me every week. So it's going to be a lot of fun. Phil has done a guided training with me, so he knows how awesome it is. So you can ask him directly if it's worthwhile or not, if it's worth your time. Well, I hope to see you in another webinar. And if you missed any part of this, I'll email you a video tomorrow. So I'll put the whole thing on YouTube, and I'll email you a link so you can watch the whole thing again. All right, guys, thanks a lot. This was awesome. I hope you enjoyed, and hope to see you soon. All right, bye. See ya.